back to my YouTube channel. As you all know that I am Impana S from Sri Venkateshwara College of Engineering, Bengaluru, from the Department of E&CE. The subject is Network Analysis and the subject code is BEC 304. So, I am going to explain about dependent sources. Introduction to dependent source. In network analysis, dependent sources play a crucial role in understanding circuit behavior. These sources rely on other circuit variables such as voltage and current to determine their output. This presentation aims to explore the principle and applications of dependent sources in electrical engineering. There are four types of dependent sources, which is of voltage controlled voltage source, voltage controlled current source, and the another two is current controlled current source and current controlled voltage source. The dependent sources are categorized into voltage and current source. A voltage dependent voltage source output voltage proportional to another voltage, while a current dependent current source output current based on another current. Understanding these type is essential for effective circuit analysis. Application in circuit design. Dependent sources are widely used in amplifiers, oscillators, and feedback system. Their ability to provide dynamic responses based on the circuit condition make them invaluable in analog circuit design. Understanding their behavior is crucial for optimizing performance in various applications. Understanding VCVS means voltage controlled voltage source is a dependent source where the output voltage is proportional to the input voltage. This relationship is crucial in circuit analysis as it allows for precise control of voltage levels within a network. In this presentation, we will explore about voltage controlled current source and the significant role in electrical network system. Understanding the principle of applications of VCCS is crucial for designing efficient circuits and enhancing performance in various electronic applications. Understanding current controlled voltage source. The current controlled voltage source are devices that produce a voltage output proportional to the controlled current. They play a crucial role in linear circuits, allowing for precise control over voltage levels. Their categories make them essential for various applications in electrical engineering. Fundamentals of current controlled current source. The CCCS is a dependent source. The output a current proportional to the another current in the circuit. This relationship is defined by the gain factor, making CCCS essential for modeling and simulating various circuit behavior in network analysis. So, for understanding the dependent source, we have to let us see the sum. So, this is the first circuit which I am explaining the dependent source. So, here in this there are two dependents which is called Ix and Iy. There are two voltage sources which is of 5 volts and 10 volts. There are three resistors which is of 5 ohm, 5 ohm and 10 ohm. So, by applying KVL rule, we have to find I1 and I2. In this network, loop 1 and loop 2 contain dependent source like Ix and Iy, where in the loop 1 the Ix equal I1 because it is placed only in the loop 1. In the loop 2, Iy equals I2 for the same reason. So let us apply KVL rule to find currents. So for applying the KVL rule for loop 1, we will get 5 minus 5 I1 minus 10. Here it will become I1 minus I2 because the 10 ohm resistor is placed in between the I1 and I2. By explaining the another concept, when the current is flowing through negative to positive, it is negative. From the positive to negative, it is negative. So for the further simplification, 5 minus 5 I1 minus 10 I1 plus 10 I2 minus 10 I2 minus 5 I1 equals 0. So it will become minus 20 I1 equals minus 5. So apply KVL rule for the loop 2. Minus 5 I2 minus I1 minus 10 I2 minus I1 plus 5 Ix equals 10 volt. So substitute the value of I1 as Ix or I2 as Iy. We will get 20 I1 minus 15 I2 equals 10. So using the equation 1 and equation 2, we can find out I1 and current I2. So in the equation 1, it is minus 20 I1 equals minus 5, where the I1 will become 0.25 ampere. Let us substitute the value of I1 in the equation 2, where it will become minus 15 I2 equals 10 minus 20 I1. So 20 into 0.25 we will get 5. So 10 minus 5 it will become 15. So I2 will become 0.33 amperes. Let us see the another problem where we have to apply 3 loops. We have 3 loops and we will get the current as I3, I1, I2 and I3. So here in the loop 3, the I3, there is a one dependent sources called as 1 ampere. So I3 it is flowing from positive to negative, so it is minus 1 ampere. So and the I1 is Ix and the Iy is I2 minus I3. So let us apply the KVL rule to find out the currents as I1 and I2. So KVL, by applying the KVL at the loop 1, it will become 5 volt minus I1 minus Iy minus I1 minus I2 equals 0. Now multiply minus 2 I1 and both I2. It will become minus 2 I1 minus 1 equals minus 5. So the final equation is I1 equals 4 by 2. So the I1 is 2 ampere. Let us substitute the value of I1 in the 2 amperes and let us apply the KVL rule for loop 2. By applying KVL at loop 2, it will become minus I2 minus I1 plus Iy minus Iz minus Ix minus I2 minus I3 equals 0. Let us multiply minus symbols to the both sources. It is of minus. So here there is one minus term and the plus term which is of same, it get cancelled. So minus 2 I2 equals 0. So I2 will be 0. So the value of I1 is 2 amperes and the value of I2 is 0. Thank you.